In this video, I'm going to demo an app that pulls the information for any stock's quarterly earnings call and allows you to summarize it, ask questions, get answers, and extract insights from the information. This is the app, and I can use it to load any stock's earnings call information. So right now, it's loading the data from an API. Once this data is loaded, I'm going to get a message. And I can start asking any questions I want about the information in the earnings call, or I can just do a summary. So this gives me a basic summary of the topics discussed in the call, like revenue growth, some of the long-term targets, margins, a goal of achieving #1 market share, and a little bit about guidance. I can also ask it specifically, what was earnings guidance? It gives me a correct answer, very succinct. I can ask it anything else I want, like what were the key drivers of financial performance? And again, it's delivering some decent insights here. I'm doing this using OpenAI's large language model, GPT 3.5, and also a technique called semantic search. So this particular application is for finance and stock research, but the techniques that are being used can really be applied to any domain and a wide range of different tasks. The motivation is to use AI to get exactly the information and insights you need from large quantities of complex data. And of course, this saves people time, it saves them energy, and it makes you better at whatever it is you do. The application will get the data from a company's most recent quarterly conference call. And these conference calls can be great resources for insights on the company, but they're often fairly extensive. This one is about 10,000 words, and the insights are often buried deep within this text. So the idea here with the application is that it's extracting exactly the information you need, so you don't have to go through all of this text yourself. But the techniques used can also be applied to any domain and a wide range of tasks. It can also be applied to much larger data sets, as well as multiple documents. The technique that makes this work is called semantic search. And what this does is it's a way of searching text by actually understanding the meaning of that text, as opposed to just trying to match keywords. For semantic search to work, we need to convert the raw text into something called a word embedding vector. So this is just a numeric representation of the text that embeds its actual meaning. If you had a data set of facts and you wanted to search that data set for sentences that could potentially answer the question, what is artificial intelligence? Traditionally, you would use keyword search. And keyword search would yield the first sentence, which is the Institute of Intelligence released research supporting the use of artificial sweeteners. Now, this has nothing to do with the question being asked, but the reason why it's delivered is because it has 2 words in common compared to sentence 2 that doesn't have any words in common. Semantic search, however, works by actually understanding the underlying meaning of the text. And semantic search would properly yield sentence number 2, which is computer systems that can learn from experience and operate autonomously. Semantic search will determine that this sentence is more related to the question, even though the 2 don't share any words in common. I'll walk through how semantic search word embeddings in GPT are used in this app. Here we have the user interface. I can enter any symbol. This time I'm going to enter in Tesla. So what it's doing is the user interface submits the symbol to a financial API, which then returns the raw earnings call text. The program takes that text and divides it up into individual text chunks, and then each of those chunks are processed and converted into word embeddings, which are then loaded into a database. Once this happens, a message is sent to the user interface, which we see right here, indicating that now we're ready to ask questions. So we can submit a question. This time I'll ask, what is the future growth outlook? And this question is then converted into a word embedding, which is used to find the most similar vectors and associated text chunks in the database. Those text chunks, along with the original question, are then sent to OpenAI's GPT 3.5 model, which return an answer back to the user interface, which we can see right here, giving some pretty good insights as to what was discussed on the call. And then I can continue and I can ask it additional questions. So one of the things it mentioned was the Cybertruck. Why don't I ask, will the Cybertruck contribute to earnings in 2023? According to Elon Musk, the Cybertruck will not be a significant contributor to the bottom line in 2023, but it will in the following year. So that's great. Another very interesting, very quick insight from the earnings call. But how do we know that this information is correct? So one of the things that's important to consider when using large language models is sometimes it can make information up, and it can do this in a very convincing manner. This is called hallucinations. So one of the fail-safes built into this app is that we're also returning the original text from the conference call that's used to come up with this answer. So Elon Musk says that the Cybertruck will not contribute to the bottom line in 2023, but it will in the following year. We can click here to see what information was used to come up with that answer. And when we search this text, we will find right here, and to be clear, for 2023, Cybertruck will not be a significant contributor to the bottom line, but it will be into the next year. And this is directly from the conference call. Another thing we can do to avoid hallucinations is the way we engineer the prompt, or we give instructions to the model not to use any information outside of the text provided. So here's an example. I can ask, what is Elon Musk's birthday? Now, GPT definitely has this information, but it's not going to be in the conference call. And the app correctly indicates the text does not provide information about Elon Musk's birthday. The potential of this is really incredible if we think about how it can be applied to larger data sets, custom data sets, and also different formats of data. I'm really looking forward to expanding on this project and taking it to the next level. If you found this interesting, then please subscribe and like the video. Also, I'd love to hear any feedback, any questions, and any comments. Thanks for watching, and goodbye for now.